Okay, this is an example on how to use the formula of order reduction to find the second solution. So this is the problem. They are giving us a differential equation here, and they know the first solution. How did they get the first solution? We don't care about that. The task is to find the second solution. Okay, now, then we have to find the second solution using this formula. The second solution is equal to w of x times my first solution, where w of x is equal to this formula that we developed on the previous video. Okay, now, but you have to be very careful. We developed this formula assuming that the differential equation is something like this. Second derivative plus p of x, first derivative, plus r of x, y equal to 0. Now, in order to use this formula, we need to make the shape of this formula, of this differential equation. That means that the first coefficient must be 1. So we have to make this differential equation, we have to make this 1 in order to get the proper p of x. Now, why we have to make this equal to 1? Because this formula was developed using this assumption. If you don't have this, then the formula doesn't work. Okay, so what we have to do is to divide by x squared, 1 over x squared times my differential equation, x squared second derivative minus 3x first derivative plus 4y, and the same in the other side, but we don't care about the other side because it's equal to 0. Okay, so what you get here is second derivative here, this divided by this is going to be minus 3 over x and x squared, and then first derivative, sorry, plus 4 over x squared y equal to 0. Now, because now we comply with the shape of the differential equation, this means that this little guy is my p of x for the formula. Now the r of x, we don't care about the r of x because it's not included in this formula. So the important thing is the p of x along with the minus. Don't forget the minus. Okay, so let's calculate w of x. W of x is equal to integral of the exponential of the minus integral of p of x, in this case minus 3 over x, differential of x, divided by my first solution. My first solution is x squared, and then x squared differential of x. Okay, let's solve this one. This minus and minus becomes positive, so it's going to be the integral of the exponential of the 3 goes outside of the integral, and 1 over x in the integral is going to be 3 the natural log of x over x to the power of 4 differential of x. Now, we cannot cancel the exponential and the natural log, so what we have to do is to take the 3 to the power and then cancel the exponential and the natural log. So this is going to be equal to the, this is exponential x to the power of 3, sorry, over x to the power of 4 differential of x. This is just reduce it to 1 over x differential of x, and the result of this is the natural log of x. Okay, so that is the calculation of w of x. My second solution then is w of x. We just calculated natural log of x times my first solution, and my first solution is x squared. And this is how we get the second solution. Very easy for this problem. Now, there is a set of problems in the homework that calculates the second solution. Now, the homogeneous solution, because it is homogeneous, equal to 0, the homogeneous solution is just the linear combination of linear independent solutions. Okay, so the homogeneous solution, the final solution, is just C1, my first solution, x squared plus C2, my second solution, the natural log of x times x squared. And then we get the final solution. Okay? On the next video, we are going to see the case of repeated roots, which we left in the previous video. What to do when we have repeated roots on constant coefficients differential equations. See you.